Hello and welcome to CS10 Discussion 13, Python 3. Woo! My name is Brendan and I'll be giving this short part of the talk. List comprehensions. So list comprehensions are this incredibly useful feature in Python. You can condense a for loop, a keep, a map, a filter all into one line, and this might prove incredibly useful as you're building these massive final projects. You might find that you want to shorten some of your lines of code, shorten a for loop here and there, and list comprehensions are going to be incredibly useful if you want to do that. For list comprehensions, we know they're useful, but what do they look like? So this is the general format for a for loop. You have this expected output that goes here, and it's for every item in your list. Which, if you may recall, this looks incredibly similar to a for loop. So I went ahead and coded this for loop that will exponentiate, or x times x, every item of the list if it's greater than 4. Or in other words, if x is greater than 4, then x becomes x squared, and we add it to our new list. This is up to 6 lines of code, just for this simple x squared function. For list comprehension, we'll be able to condense all of this into one line. And it's really fascinating because there's direct parallels between a for loop to a list comprehension, and I color-coded it to make it more apparent. So for every x in my list goes at the end of your for loop, and you're telling where to find your x. The beginning, this green portion, is going to be your expected output. So this is what you want Python to do to your x for your items in your list. So for us, we want it to be x times x, or x squared. And we're going to do it for every item in our list. So already, we condensed this for loop into one line. So the only thing we're missing now is the keep, or the if x is greater than 4. And have no fear, list comprehensions have this feature as well. So they have this feature where you can import a function here, do whatever you want, almost like a map. You do it for every item in your list, but you only do it if this condition is met. So for us, I color-coded it again. It's going to be if x is greater than 4. So now we have x times x for x in my list if x is greater than 4. So that's going to do x squared for every item in your list if and only if x is greater than 4. And we can abstract that out to this general format where it's a function over x, or a function of x, for x in list if this condition is met. And that works almost for any type of list comprehension that you're ever going to build. And now we condense all of this into just one short line. You may recall that this looks really similar and sounds similar to Snap. So we have different features that include map and keep in Snap, and it draws right over to Python. So for map, it would be this function over a list. For you, it's just going to be x times x for item in my list, which is the same exact format. The keep is turned into just a simple if statement. The other core thing is Python has its own features as well, called map and filter. So map in Python looks almost the same thing as the map you're used to. So instead of list comprehensions kind of making it seem like it's almost map, but it's kind of like not as obvious, Python puts another feature in where you can actually call map as you know it and love it in Snap. So we call map, and it's going to take in a function. So for me, I put double there, and double just takes in a number and returns it as doubled. And it has to take in a list of input, which is the same format as Snap, where you take in a function with the empty blank, and then you put in a list of inputs. Filter is going to work similarly, where you call filter over a function. I did even, which is just going to report true or false, and then a list of inputs. A big thing to note here, or two things to note. Even, I didn't do even open parentheses. It's just I called the function name. The second thing is if I wanted to see the values that this filtered, I would have to call list on the outside. And I'll show that later as we start to get into live coding. This alone returns a filter object, which we can use to like in a for loop or something like that, but we can't really see what it is. So right now, I want you all to get started on trying these out. We kind of understand the anatomy of them now. So let's try to write a list comprehension for this, and let's also try to do it with map and filter, the two Python functions. At this point, I would recommend you pause the video, take out your laptop, open the terminal, and try to code this for like a few minutes. Welcome back. I hope you had a good chance to try these problems out, work with them, and maybe solve them. But now we're going to go over it. So the first one we're going to do is use some built-in map and filter functions. So we need a function that takes the first letter of a word, and then another function that's going to be like a predicate that's going to tell us whether the length is greater than 5 or not. So I went ahead and built these. So I made a function first that takes in a word and gives me the first letter. I also went ahead and made 5 greater, which is going to return if the length of the word is greater than 5. So now we have to make our filter function, then our map. So for the filter, note that in Snap, it filters it or keeps stuff, and then it maps it. So I want to do it in that order too. For filter, our function is going to be 5 greater. So we're going to keep only the words that are greater than 5, and I made a list called favorite TA. And it has a bunch of words of different length. Got it. And we can try that out. So let's try f equals filter 5 greater favorite TA. And note that I did 5 greater without open parentheses. You're just calling the function name. You're not doing like the open parentheses function call. And awesome. And to see what we put inside f, you can do list of f, and it will tell us memorable, altruistic, notable, scholar, is it. For map, we're going to need a function, so I'm going to call that first function we wrote earlier, and then we need to write it over a list. So we need to turn f into a list and do this, and then that will work. So let's go ahead and rewrite our filter 5 greater with favorite TA. F is defined. Now let's call the map. That's our set. And let's call a list of M. And we get Monty. And if you remember, our favorite TA list was my favorite TA is memorable, altruistic, notable. Their name is Skylar, or is it? And when we did our map and filter, we got Monty. Also note that if you want to do the combination, you very easily could have done the filter here, then mapped the entire thing over that. So you're going to map first, then you're going to turn this filter into a list. So this whole thing is now a list. And let's make sure we have the right amount of parentheses. And then that would work as well. So now let's try to think about how to do this as a list comprehension. I remember telling you to think of it as like a for loop. And the first element of our list comprehension is going to be what we want the output to be. Recall that we want the first letter of everything. So I'm just going to do word 0 for word in favorite TA. Now this will give me the first letter of every word on my list, but I don't want that. I only want it if the length of word is greater than 5. And we can go ahead and try that out. And if I call list comp, we get Monty again. So this combo and list comp are the same exact thing. It's like a map and a filter, but two completely different ways. And this has been list comprehension, so now I'm going to pass it off to Monty to go try some harder problems with all of y'all.
Hey everyone, this is Monsi, and today I'll be going over the list comprehension practice on your worksheet. So let's get started. So before we start, let's do a quick review of how to build list comprehensions. So if we have a for loop that looks like this, where we're going through a list, and for every single item, if some condition holds true, Then we apply a function to that item and add it to our new list. This block of code becomes a really, really good candidate for a list comprehension. So what we do is we create the square brackets for a list comprehension. These square brackets are really, really important. Without the square brackets, even if your code is correct inside the list comprehension, it won't run. So first we get the function that we're applying to each item. So that's the x plus x. Then we just copy over the for loop entirely. So we say x plus x for x in my list, and then we copy over the condition. And that's our entire list comprehension for those 4 lines of code, which is really, really awesome. So another thing to note is that this if statement at the end is completely optional. You only need to have that if you have some condition that you're applying to these elements. If not, you can just include this part, and this part is mandatory. So that being said, another way you can think about list comprehensions is first, what am I looping over? When am I keeping items? And for the items I keep, what are we doing to them? And if you actually read this list comprehension, it reads a lot like English. It says x plus x for x in my list if x is greater than 5. Another way you can think about this is that this last part at the end is a keep statement. We keep all of the items that are greater than 5, and then we apply the plus block to them. So we map plus over them in my list. So that's 3 ways to think about a list comprehension. That being said, let's get started with some practice. So this is the first question from the worksheet. It has a dictionary where the keys are the names of discussion TAs and the values are numbers, their favorite numbers. And then there's a list of nums. And what it says is use a list comprehension to return a list of the TAs whose favorite numbers are in nums. So what I would suggest doing is if you feel comfortable with list comprehensions, or even if you don't, try to refer to the past 2 or 3 minutes of this video and work on this alone. Okay. Now, if y'all want to go over it, I'll do that. But again, if you want to work on it, you can just pause the video and work on it on your own. So, the way I like to answer these questions is I like to analyze what's actually going on. So the first question I ask myself, or I basically refer to this. So the first question we ask ourselves is, what are our items and where do they come from? So in this case, our items are the names of TAs and they're coming from fave numbers. So what we do is we add that for part of our list comprehension to our list comprehension. And so we say for name in fave numbers. Now the next question is, when should we keep an item to put in our output? In other words, are we filtering items at all? And in this case, we're totally filtering items. We're only getting the names of the TAs whose favorite numbers are in nums. So what we do for that is we have a name. We're already iterating over the keys in the dictionary, and we have to figure out if those keys' values are in nums. So what that looks like is this. So if fave numbers name in nums. Now the last question to ask yourselves is for the items that we keep. In other words, for the names that made it through this if statement, how do we include them in our list? Do we apply a function to them or do we return them as is? So here we're iterating over all of the names in fave numbers. And once we get the name, we kind of just want to return it back. We don't need to apply a special function to the name. So all we got to do is the variable here is called name. We said for name in fave numbers, so we put a name at the beginning of our list comprehension. And now our list comprehension is complete. It reads as English. We say for a name in fave numbers, if that name's fave numbers is in nums, return to me the name. Awesome. So let's move on. So now this question asks you, or this question gives you a list of lists, and it asks you to return a new list where each item is the sum of each of these sublists. So you take 1 and 2, add them and get 3. You get -5 and 4, add them and get -1. And it also gives you this this useful helper function called sum, which takes in a list and outputs the sum of its values. So again, if you'd like to, pause this video and take some time to work on it on your own. If not, I'll be going over it now. So for this one, I like to use a similar method as we did for the last question. The first question we ask ourselves is what are our items and where do they come from? So in this case, we're trying to go through every single item of list of lists and find the sum. So the items in our final list comprehensions result should be the sum of each of these sublists, which means that we have to go through each of these lists one by one and find their sum. So what we can say is for LST in list of lists. And you may notice a lot of times when the TAs or when Dan or when really anyone else has been typing in Python, we don't type out the word list as a variable name. The reason for that is in Python, the word list actually refers to this list data type. So we don't like to use that as a variable name. Similarly, we don't like to use things like int or string as variable names because they refer to types of variables. So what I usually do is I just take out the I in list, and I say for LST in list of lists. So now, the next question we can ask ourselves is there a condition? In other words, when I iterate over these sublists, is there something telling me which sublist I should find the sum of? Or should I find the sum of all of them? In this case, we just want to find the sum of all of them. So we don't really need that extra if statement. And again, it was not mandatory, so we just won't include it. So now the next question says, for every single item we keep, so for every list in list of lists, what should we do to it? And here we want to find the sum of every single list in list of lists. So we apply the sum function. So we say sum of list for list in list of lists. I just said list 4 times. Awesome. So now we'll be moving on to number 3 on the worksheet. So it says, in the following questions, we will be writing code to find the index of an item in a list. The key here is you may assume that the item you are looking for appears in the list exactly once. So now it first asks you to write the function recursively in Python. So we're going to ditch list comprehensions for a second and go back to recursion and talk about how we can do this. So the first thing to think about here is what is our base case? What is the simplest instance of finding 5 in our list? And I think a lot of times it's really, really tempting to say that our list is empty. Because if our list has no elements, or if it has one element, it's tempting to think that that can give us the answer to what the index of 5 is. But for example, in this case, what if we were shaving all but first off of this list, and we were just left with the list 7 at the end, or an empty list? Does that tell us anything about the index of 5? It doesn't. So in this case, we want to find a base case that will always know what the index of 5 is if it's given a certain type of list. And what we can do here is we can take advantage of the fact that the item we're looking for appears in the list exactly once. So then in which case do we always know what the index of the item we're looking for is? One scenario where we always know what this index is when the item is the first item of our list. In other words, if our list was just 5, 7 here, we would know that the index of 5 is 0. Cool. So now we have to do our recursive case. And one way I really like thinking of the recursive case is, if we had the answer to a smaller problem, how would that help us solve this bigger problem? So a lot of times when we do recursion, we think of doing all but first of our list. And that's great. So what if we had find index of 5 in the list 5, 7? We already know the answer to that because it hits our base case. It returns 0. So now how can we use that answer to find the index of 5 in 2, 5, and 7? So if we know the index of 5 in a smaller list where the first item is shaved off, all we have to do is add 1 to that to get the index of 5 in this bigger list with that first item there. And we see that here, where find index of 5 and 5, 7 gives us 0, and find index of 5 and 2, 5, 7 gives us 1. So what we can say is else return 1 plus find index of item in all but first of the list. And this syntax gives us all but first of the list. Cool. So now the next question goes back to list comprehensions, and it asks us if we can do this exact same thing with just a list comprehension. And this is a really, really tricky task, so I would definitely recommend you to try it on your own before we go over it. So pause the video, try it on your own, and I'll be going over it now. So for this one, I actually want to go to a text editor and convert this to how I would write it in a for loop. So here is our file, and we're saying def find index item in a list. So one way I like to do this is I like to see how we could do this in just a normal for loop. So if we were just doing a normal for loop, one thing we could do is we could say for I in range len list. Again, what that does is it sets I to the value 0, 1, 2, all the way to the length of the list minus 1. That's useful because I can serve as an index. And so now what we can say is if the ith item of our list equals the item we're looking for, return I. And that gives us the index of our item in the list. But this doesn't really neatly look like that for loop that we converted to a list comprehension. Just as a reminder, the for loop that we converted to a list comprehension looked something like this. So again, we have the for loop that we need. Or sorry, this translates to x plus x for x in my list if x greater than 5. So what this function that we just wrote does have is it has the for loop and it has this if statement, just like this and this. But unfortunately, in this function, we were appending to a new list, and we took whatever we appended to the new list here. So how might we rewrite find index so that it also appends to a list? Because then we can turn it directly into a list comprehension. So def find index item in list. So let's define a new list. And let's say for I in range len list if list I equals item. And now maybe instead of returning I, let's add I to our new list. So let's say new list dot append I. And again, the reason we're creating a new list and we're appending to it is we want our for loop to look exactly like this for loop, because we know that this one translates neatly into a list comprehension. And so once this loop is over, we know that new list has exactly one value, because the question guaranteed to us that item appears in list exactly once. So if we want to get the only value in new list, we can say return the first item of new list. This seems a lot less intuitive than doing this, but the advantage of this is that it translates directly into a list comprehension. So remember, when we translate this to a list comprehension, we first want to get the thing we're appending, so I. Then we copy over our for loop, and then we copy over our if statement, which is beautiful. So now we said I for I in range len list if list I equals item. Now the only thing missing here is that this question is asking us to return one number. It's not asking us to return a list of the number we're looking for. It asks us to just return that number. So just like we did in line 12, where we knew that new list only had one value, so we returned the 0th item, Similarly, in line 14, we can say return the 0th item of this list comprehension. Because we know that this list comprehension will return exactly one item, because item appears in the list exactly once. So that's the answer to this question. We say I for I in range len list if list I equals item, and then grab the 0th element. Awesome. Well, that's it for this worksheet. If you have any questions, please feel free to post on Piazza. Thanks.
Hey folks, so we're going to be talking a little bit about the basics of lambdas today. And so pretty much what I want to go over first is just why do these things exist in the first place, how can we use them, what are their structure, basics like that. And then we're going to go over the first couple practice problems that appear on your worksheet. All right, so let's get started with just what are lambdas? When do we use them, how do we use them, or what are some of their features? The first thing I want to highlight is that they're just one-liners. They're one-line expressions that are evaluated and returned. And because you're restricted to only using one line, there's only so much you could do with these lambda expressions. So we usually use them for ease of coding nature, right? If you know you're going to use a one-liner, you don't have to go through the whole def statement syntax to be able to use that function. Instead, we can use lambdas. And because of this one-line nature, oftentimes they end up being simple functions. And I don't want to use simple, meaning that you can restrict their usage so much as their complexity. You know, it gets a little bit more confusing using for loops. That's not going to be as possible in lambda expressions. Most of the times they're just simple, or not simple, but quick one-line expressions that return a result. So it restricts their functionality a little bit, but as we've seen in this course, sometimes one-liners can get quite complex. The last thing I want to talk about is that there's an implicit return statement in these lambdas. So they're one-line expressions that are evaluated, then the result is returned, just as if you used a return statement in a function that you defined using the def syntax. So those are some of the features of lambdas, and we can start looking at them real quick right now to see how they apply into the syntax of how we use them. So this is the lambda syntax, and I put it together with the syntax that we usually use to define these one-line functions using def statements. So the bulk of the lambda expression is to the right of the equal sign on the above line. And the equivalent of the def statement would be the expression lambda. This lets you know that the variable you're defining is going to be a function, and it's going to take inputs or possibly no inputs, and it's going to evaluate an expression. So we know that our function is called f in the lower expression, the def statement, because it comes before the parentheses, and we know that it's the name of the function in the lambda syntax because it's what the variable's name is defined as. And then in the def statement, what our arguments are going to be are defined within the parentheses coming immediately after the function's name. The equivalent to this in the lambda expression is what comes after the word lambda. And so this can be any number of arguments. Oftentimes we use one or two, but it could go up to many more, just as in the def statement. And then what's probably more interesting is, or maybe not, because they both come after a colon as a matter of fact, but you don't write a return statement. Like I said, that was implicit. Instead, you just write the expression that the arguments are used in immediately after the colon, and those arguments will be applied in that expression. That'll be evaluated and returned, just like happens in the return statement down low. That expression may or may not use the arguments that you defined earlier. It'll evaluate the expression, and then it'll return it. So I want to stress that these are equivalent expressions. It just gets a little bit quicker to type, and maybe lets the person who's reading it know that it's going to be a one-line expression using a lambda. But these are equivalent. They do the same thing, and those are kind of their analogs in each of the types of syntax. So I wanted to actually write a little bit in the Python interpreter just to give us some kind of perspective on these instead of just looking at them on slides. I should probably spell Python, right? That works. Here we go. Okay, so if I write out a lambda expression right off the bat, so we say lambda, letting us know it's a function that takes, let's say, one input and just is the identity function. It returns that input right to you. So if I hit enter here, you'll see it give us this funky Python syntax letting us know we just made a function and then we happen to not do anything with it. So to actually use this lambda, we have to set it to a variable. And like we saw in the syntax earlier, how we do this is we write, let's call this one f equals and then the lambda expression we just wrote. Sorry, lambda x returns x. So now our function is saved to a variable name, and we can call it like we would call any other function. So as you can see here, our function is called f, and so we call that function here, and we realize what the arguments are going to be because we type them in after the parentheses as we usually do. This 3 is applied to the input variable x, and then the expression after the colon is evaluated. In this case, it's just the value of x, which is 3, evaluated and then returned, as we see down here. Yeah, that's how we begin to write lambdas. I might as well show you how we can use multiple inputs. So if we define a new variable, g, we make a lambda expression for that, and we have 2 inputs, x and y. So you see, it's almost as if we had the parentheses around here implicitly. I kind of like to think of it as. So you just write it out like you normally would, but without the parentheses. So your first argument, comma, your second argument after space, or no space, but you know, use the conventions. And then once we write the colon, we know we're going to start moving into our expression that we used. So let's pretend this, or let's not pretend, let's write it. This lambda takes in x and y and returns the 2 values added together. So now we can call g like any other function, 2 and 3 is the inputs, and see what it'll give us. So it applied 2 to the input variable x, 3 to y, and then it evaluated the expression using these. Yeah, so it works just like any other function. It just, the syntax gets a little bit of getting used to, but it works swimmingly once you get used to it. Okay, let's go back and look at some practice on your worksheets. That's what we would do in discussion, right? Okay, here's question 1. So the question is, write a lambda function called f that takes in a number and outputs that number squared. So why don't you take a second right now, think about it, try it, and then we'll talk about it in 3, 2, 1. Here we go. So here's the answer. Reads lambda x colon x times x. And so like we saw earlier, let me exit out of here so I can point with this bad boy. Lambda lets us know this f is going to be a function. It takes in one number that takes in a number, x, we're going to call it as our variable. And after the colon, we're going to write the expression that we're supposed to use for this lambda. In this case, it outputs the same number squared, which is equivalent to x times itself. So that's how we write it. We could take a look at it here just to make sure it works. GH, I guess, is the new one. Lambda x colon x times x. And this will take in a number, say 9, and give us its square. Okay, great. So that was question 1. And an important thing about lambdas is we use them just like any other function. In this case, let's take a look at number 2. We're going to use the lambda we just defined to return a list of squares of all numbers between 1 and 5 inclusive. And we're going to do this on one line because this discussion is about doing list comprehensions, right? So think about using a list comprehension to do this problem. Give it a shot, and we're going to talk about it in 3, 2, 1. Cool. So the first thing you need in any list comprehension kind of goes along the same syntax as normal, right? We have the brackets on the outside, and the statement and the syntax in the middle lets us know that we're going to comprehend over a list, I guess. But we're always going to have that for and in. So we're going to do something for each item in a list. So let's get this out of the way. This item is going over 1 and 5 inclusive. So each item is just going to be a number. We can call each of them x while we're going through it. How about that? Now let's think about the numbers that we're going over in the list comprehension. So it's 1, 2, 3, 4, and 5. So how the syntax that we use to get numbers within a certain range is actually called range. And we want to get 1 through 5 inclusive. Well, the first number you put into range is inclusive, so we'll just call that 1. And the second one's not inclusive, so we're going to have to go 1 further than 5, right? We're going to have to grab the range from 1 to 6. So these are the numbers we're going to iterate over. That'll give us 1, 2, 3, 4, and 5. So for x in that range, what are we going to do? Well, it says it's going to take a function f and return a list of the squares of all the numbers in our range. Well, we wrote a function f that takes in one argument and returns its square. That was our lambda expression. And we can use it just like any other function that we define, which I've been reiterating several times, but it's the big theme of lambdas. They're just functions. So f of x for x in range 1 to 6, that'll get the job done. We can take a look at it if we want, because I already defined, it's going to be h in this case, that's how I defined it. Let's take a look. H of x for x in range 1 to 6. End that out. Look at that, we got 1, 4, 9, 16, 25. That looks just right to me. Okay, so those are the basics of lambdas. Again, we've been using expressions that only use the input variables in the expression. But again, this could be like x times 5 or something like. You could use constants in here. So you can start playing with it a little bit more, which if you want to see how that could be messed with a little bit more, take a look at the challenge problem. I know we're going to have a video about that. But thanks for listening.
Aaron. To go back to the original warm-up problem we had with list comprehensions, I want to bring back how you could do it again, but with lambda. So yet again, a third way to do it. Recall we had to make these functions ahead of time and like incorporate them inside our code. If we didn't want to do that, we could do the map filter together with lambdas. So for this lambda, we're going to want it to take an input x, and this is kind of like our word, and we want it to just report x slice to give us the first item of x. For this one, we're going to again do lambda x, so it's going to take in the input x, and then we want it to report if the length of x is greater than 5. So this would be a true or false statement of yes, true, it is greater than 5, or false, it is less than 5. And this works the same exact way as it does by coding it this way. So yet again, this is a third way to do it. You can do it with a combination of map and filter, you can do it in a list comprehension, or you can even do it with a lambda.
Hey everyone, my name is Monsi, and today I'll be going over higher order functions in Python. Before we get started talking about higher order functions in Python though, let's go over what they look like in Snap. So, as you may recall, a higher order function is defined as any function that takes in another function as an input. And 3 examples of this, probably examples that you're tired of, are map, keep, and combine, each of which take in a function as signified by this gray ring, and a list, and it applies that function to the list in some way. So recall that we have this ring so that Snap knows to treat a function that it's given as a piece of data. An example of this is something that we can see with the plus block. So if we just were to call this plus block, it would implicitly put zeros into all of the blanks and evaluate it as such. So if we want to tell Snap to kind of freeze this function in time, to not evaluate it and instead treat it as the plus block as a whole, not as the value 0, what we can do is we can ringify it. And then when we click on it, instead of seeing 0 output, we see this plus block. Then if we want to actually evaluate that function, what we can do is we can use the call block. And we have the call block take in some sort of reporter and inputs, and then it's really awesome and it'll call that function with the inputs. Similarly, if we had a command block that was ringified, we could call it with the run block. So a quick thing, we see a block for reporters and a block for command blocks, but we don't really see one for predicates. If we wanted to run a ringified predicate, we could actually use the call block as well. The call block takes in reporters, but remember that predicates are just special kinds of reporters. So the call block works with reporters and predicates, and the run block works with commands. So that being said, let's actually go to an example of a higher order function in Snap. So here's an example that I kind of just wrote up. It's called apply function. Just a sec. And what it does is it first evaluates the predicate that it takes in on its input. If that predicate reports true with the input, then it'll apply this reporter to the input and output the value. So an example is here. It'll first check if the input list over here is not empty, and because it's not empty, it outputs the length of function applied onto that list. Here, however, this list is empty, so it doesn't satisfy this predicate. And so running length of on it reports cannot apply function. So if we were to write this function on our own, apply function with reporter on an input if a predicate, what we first need to do is we need to evaluate the predicate on the input. So what we can do is we can say if calling that predicate with that input returns true, then report whatever calling the reporter with that input outputs. And otherwise, just say cannot apply function. And here it was a bit annoying. We had to use some calls, we had to use some ringified functions, but we were able to get it to work. Which is awesome. So now that we're done talking about higher order functions in Snap, let's go ahead and look at what they would look like if we were to write them in Python. Just replace it. So what we can do is let's actually, there. We can drag that over, and now we can refer to our awesome Snap code while we write this block in Python. So let's say def apply function takes in a reporter, an input, and a predicate. Notice here we didn't have to do anything special to tell it that it was a function. In Snap, what we would have to do is we would have to apply a gray ring saying this is where a reporter goes, this is where a predicate goes, but in Python we can just treat them as input names. And what's really, really beautiful is if we want to actually call this predicate with the input, we call it just like we would call any other function. We would just say if pred with the parentheses input. And that's really, really cool because we called it the same exact way we would call any function. Whereas in Snap, instead of like putting inputs in, we had to actually use the call block. So Python is very, very elegant when it comes to higher order functions. So we say if pred called on input, then return reporter called on input. And otherwise, return cannot apply function. And what's really, really cool again is that if we wanted to call this function, what we can do is we can just put in the reporters we want. So here, if we go back to our Snap code, the reporter we passed in was length of, and in Python that's called len. An input is 1, 2, 3, and a predicate, and now this is where it gets a little ugly in Python. In Snap, we were able to kind of just chain together these these blocks, and kind of just pass them in. Fortunately, in Python, the things that you put in have to be defined as functions. We can't put in a function of a function. So what we'll do is we can say def not empty list and return if the length of list is greater than 0. So what we did was we basically just created this not empty and we put it in here. And so now if we want to run this, let's get our terminal window open. So I'm already in the folder that I saved it in. So what I would do is I would say python3-i, and the file was called demo.py. And that didn't output anything. The reason it didn't output anything, even though I called this function here, is because we didn't print it. A nice analogy that I like to use is that whatever we see on the terminal here is the same thing that we would see on the stage in Snap. And remember that on the stage in Snap, we don't see anything unless we say it. Similarly, in Python, we don't see anything in this terminal window unless we print it. So let's print this, and that should give us 3. And let's also actually print this, expecting 0. And what we do is every time we edit a function, we have to type exit on here, and then we can run it again, it said 3 and cannot apply function, which is awesome. So now that we've gone over conceptually what these look like, let's actually go over the example on the worksheet. So this worksheet is called Verify Pattern. This question is called Verify Pattern. What it does is it takes in a method, an author, and an argument. And what it does is it verifies that that author is Skylar. And if that author is Skylar, it calls the method with the inputs. If the author is anyone who's not Skylar, unfortunately, it'll return that person's name and it'll say their methods aren't patented. Also, for all of Skylar's students who are watching this, his patent on his however many step, fractal, whatever, is not patented. Neither is mine. Anyway, if we were to actually write this function, this is what it looks like in Snap, but let's just go ahead and write it in Python. So it's called def verify patent, takes in a method, an author, and an arg. Again, the first thing we do is we check if the author is Skylar. So if author equals Skylar, then we return whatever the method returns with the arg. So return method called on the argument. And again, this is consistent. We said if the author was Skylar, call the method with inputs arg. And then otherwise, we want to say that the author's arguments are not patented. So what we would say here is author plus methods are not patented. And notice here that usually we can just use single quotes or double quotes to specify a string. But here, because my string had a single quote in it, I had to use double quotes around that string to define it. So now if I save this, let's go to my terminal window, Python 3-i demo, it says cannot apply function. Those were these print statements, and now let's run verify patent. So if I verify patent with the len function, again, the author, Skylar, in the list 1, 2, should output 2. And if we ran it with Monsi, it would say Monsi's methods are not patented. Awesome. Well, that's higher order functions in Python. If you have any questions, please feel free to post on Piazza and I'll answer them for you. Otherwise, have a great break or dead week or whenever you're watching this.
Hi there, Skylar here, one of your discussion TAs, and I'm going to be going over the challenge problems from the worksheet. So just a quick note before we get started. The problems in this section are a bit more challenging than the rest of the questions on the worksheet, but they are exam level difficulty. So this is the caliber of question we'd expect you to be able to solve on your paper final exam, and I think you're fully capable of doing that with the tools we've taught you. And a few of these are actually taken from past final exams. So let's take a look. So this first problem, we create a list, and then we put a list in the list, and then we do things to the list within the list, and then we have a list. Okay, so the bad way to solve this is to look at it and stare at it and wonder what happens. The good way to solve this is to actually draw things out. So we're going to think like a computer and execute this systematically. So we have this variable lst, list, and we set it equal to a list. Now if you remember when we talked about mutability in Snap, you don't actually set variables equal to lists. There's the world of variables and there's this separate other world of lists for whatever reason, and the only bridge between the two is a pointer, this thing that we draw as an arrow. You remember that from, I don't know, 6 or 7 weeks ago. And it's the same thing in Python. In most programming languages, we don't set variables directly equal to lists, we set them equal to pointers to lists. So let's draw the picture that way. And it won't matter too much for this problem, but we'll try to be precise. So we have this list 1, comma, 2, comma, bracket 3 and 4. So now I have this list within a list, where it's actually a pointer to a list. So this is what the computer representation looks like after the first line executes. Then we're going to grab item 2 of this. Okay, well, Python 0 indexed, so item 0 is this, item 1 is this, and item 2 is going to be the sublist. So this item right here, that's item 2. Okay, so we grab that and then we call .pop. Remember that pop is called on a list and it deletes the item at the specified index. Here we didn't specify an index, and when you don't specify an index to pop, it just by default deletes the last item. So we have this 4, and now we're going to just get rid of it, and our list is going to look like this. So it's going to be 1, 2, and then a sublist just containing 3. Okay, and then we're going to print out the list. Okay, well, the list is going to be exactly what we have here, so our final answer is going to be 1, 2, 3. Okay, so not too bad when we walk through it like that. The next one, we have a list comprehension. X times 2 for x in range 4 if x mod 2 equals 1. Okay, what does that mean? So remember that a list comprehension basically has 4 parts. It has, some sequence that we're going to iterate over. Then it has this thing that's similar to a for loop for x in some sequence. It just says we're going to look at every single item in the sequence, assigning it this variable name. And then an if condition, if this condition evaluates to true, we're going to apply some expression to each element. And then we're going to store them in a new list and return that. So it's the equivalent of calling map and keep in Snap. So if we look at this again systematically, I think we should break it down piece by piece. So first, what is the sequence we're iterating over? Range 4. Well, a range 4 is going to look like this. It's going to be 0, 1, 2. That is not a 2. Okay. 2 and 3. Because remember, in Python, we zero index and we don't include the upper bound. So range 4 is going to be 0, 1, 2, 3. These are the 4 numbers we're going to be iterating over, and then we say for x, so we're going to call each of them x. Okay, so now let's walk through what happens with each number. So first we're going to take 0, we're going to assign it to x. We're going to say if 0 mod 2 is equal to 1, and 0 mod 2 equals 0, this doesn't hold, so we're done. We don't even look at this function, we're done. Okay, goodbye 0. Then we look at 1. Okay, assign 1 to x. If 1 mod 2 equals 1, 1 mod 2 does equal 1. The remainder of a 1 when you divide by 2 is 1. So then we go over here and we say we'll apply this function, or this expression, 1 times 2. Okay, and then we'll store that in a new list. So down here we'll have a new list. First element is 2. Then we go up here, we grab 2, we assign it to x. Is 2 mod 2 equal 1? No, we're done. Goodbye 2. Then we take 3, assign it to x. 3 mod 2 equals 1. It does. So then we apply 3 times 2, we get 6. We store that in this new list. And this is what the list comprehension returns. 2, 6. And note that it's a list containing 2, 6. Okay, then we have this weird looking thing. We have like a join and this list comprehension. Let's start with the list comprehension because join is just a function. It's going to, operate on its arguments, and its argument is a list comprehension. So let's evaluate this, and then once we get the output, we can look at what join does. So we'll walk through this the same way we did the last one. Let's look first at the sequence we're going to be iterating over, and the sequence is University or Univ of Caliph at Berkeley .split. What does .split do? Well, what .split does is it takes in a string and it generates a list. So it takes in it operates on a string and outputs a list where each item of the list is a sub part of the string separated by whatever argument you give to split. So if I had text from a book and I put .split with comma, it would separate it into a list of substrings where broken wherever there were commas. So each element in a list would be part of a sentence up to where there's a comma. Here, we don't have that. We just have split with no arguments. So by default, it's going to split on white space, just spaces. So we're going to get a 5-element list. Sorry, let's try that again. We're going to get a 5-element list that's split up like this. So univ is the first element, then of, then caliph, and then at, and then Berkeley. Those are the 5 elements. They're all strings in a list. And that's what we're going to be iterating on. So we can draw it like this, just to remember it's a list of strings. Then we're going to assign the variable word to each element, and let's walk through it one by one. So first we assign univ to word, and then we say, okay, this is a nested expression. Length of word equals 2. Okay, well, univ is 4, so that does not equal 2, but we have a not here, so that's actually what we want. So length of univ does not equal 2, that's true, so we're going to go over here and apply our expression, and it says word 0. So what's item 0 of univ? That's u, and so we're going to create a list and store u in it. And it should be quotes because it's a string. Then we're going to look at of. We're going to go down here, we're going to say length of equals 2. It does, but we want not. The length of does equal 2, so this whole expression is not true, and we just skip of. Then we go to caliph. It does not equal 2, it equals 5, so we apply this expression, and we get the first letter, which is C. Then we do at, which does equal 2, so we're going to forget about it. And then we do Berkeley, which equals 8, not 2. So we're going to use this. We're going to apply word 0. We're going to get the first letter, B. And put that in an output list. And this is what the list comprehension outputs. Now, we're not quite done because we have to worry about this join function. But that's not too much more work. Remember that the join function operates on a string. It takes in a list of strings, and it joins everything in that list of strings, all those strings together into a single string. And it's a little bit different than Snap's join function. It's going to separate each string in the list by the string you call it on. So if I called this on hello, I did hello.join, and this, I would get a single string, u hello, c hello, b hello. No, that's not correct. U hello, c hello, b. So it would put a hello between each element. Now here I've called it on an empty string, so it's going to work the same way, but it's going to put an empty string between each element, which is just to say it's not going to put anything between each element, and it's going to just join all the strings in the list into a single string with nothing between them. So this join will just return, in quotes, u, c, b, end quote, and that's what we return. Box that up. That will be our answer. Then we have this one, which looks pretty similar. We have this join, which we don't worry about yet. We have this expression, the list comprehension. We'll start with what is the sequence that we're iterating over. And here we have the same string, but no dot split. So we're actually going to be iterating over this string. You can do that with a list comprehension. It's fine. You can give it any sequence, any iterable in Python. And here we're giving it a string. What that means that's different from our previous example is that as we go through the list comprehension, each item is not going to be univ and then of and then caliph and then at. It's going to be each letter, each character of the string. So first word is going to be set to just u, then it's going to be set to n, then it's going to be set to I, then it's going to be set to v, then it's going to be set to this space, which is still a character, and then of and etc. So it's going to be set to every single character of the string as we see whether this expression holds and apply this expression. So let's walk through it. First word, as I said, is set to u. So we say length of word equals 2. It does not. That's what we want. Length of u does not equal 2. It equals 1. So we'll keep u and we'll apply this expression, word 0. Okay, well, what's the 0th element of u? What's the 0th element of a one character string? It's just that character. So that's just going to output u. I'm going to get u. Okay, put it in a list, draw a comma. Then we're going to take n, set it equal to word. We're going to plug that in. That's the same thing. The length is 1. That does not equal 2, so this holds. So we apply this expression. The 0th element of n is just n, and so we get a lowercase n in our list. And you can sort of see where this is going. We're going to apply it to I and V and the space and every single character in the string, and the length of all of these is 1. They're all going to be kept. The 0th element of everything is itself, and so we're going to end up with a list containing all of these characters. And then we're going to apply join, again with this empty string. It's going to join them all together with nothing between them. And we're going to end up with exactly what we started with, and so our answer, I won't write it out, but our answer is going to be this string here. It's going to be, in quotes, univ of Caliph at Berkeley. That's our answer. So this is sort of tricky. Just because we call this variable word doesn't mean Python and your computer knows that you mean a word and univ is a word. No, we can call this variable whatever we want, and Python's just going to assign it to every item of the sequence. And here the sequence is a string, so we're going to look at every item of the string. We're going to end up with what we started with. All right, now we get to some lambda functions. So here we have f1. We're assigning it to lambda x, x plus x. So let's look over here in a text editor instead of me trying to draw all this out. Remember that a lambda function is very similar to a regular function in Python. We've just basically taken a 2-line function and smashed it into 1 line. So I think to better understand what this is saying, we can rewrite this lambda function as a standard 2-line function. So this part over here is going to be the def statement, and this part over here is going to be the return. They're separated by the colon. So whatever's to the left of the colon, that's like your def statement, and whatever's to the right of it, that's like your return statement. So it would normally be a 2-line function. Now it's a 1-line function. So if we rewrite it, we could say def f1, because that's the name we're assigning, and the argument is x. And we're going to return x plus x. So this is just a function that takes in a number and returns the number multiplied by 2. Then let's do the same thing for f2. Again, the part to the left of the colon is going to be the def statement, so def f2 x. And here we're going to return x is greater than 9. So this will return a Boolean that tells us whether x, the input, is greater than 9. So that's what we have here. That's the lambda functions. And then we have this list comprehension. Let's look at it the same way we did the previous list comprehensions. First, what's the sequence we're iterating over? And note that here there's no if, because the if is optional, so we can forget about that. We'll start with the sequence. The sequence here is f1, f2. So it's a list of functions, which might seem a little weird, but that's perfectly fine. We can use functions as data in Python just as we can in Snap, as you saw in some earlier problems in the worksheet. So we have a list, f1, f2, and we're going to assign this variable f to each of these functions and then apply them in this expression. So it's a little weird. Like usually we give Python the function and then we pass in an argument, but here we're actually passing in the function to this expression. But that's perfectly fine because we can use functions as data. So walking through this, we'll start with f equals f1. We'll say f1 of 10. What's f1 of 10? Well, that means lambda 10, 10 plus 10. Might make a little more sense to look over here in the editor. That's like calling f1 of 10, return 10 plus 10. That's going to return 20. So the list comprehension, our friend is going to put it in a list, 20. Great. Now it's going to take f2, assign it to f, call f2 of 10. Let's look over here. Okay, that's f2 of 10. We're going to see, is 10 greater than 9? It is. That's going to return true. And our list comprehension is going to stick that true into a list. And this is what we return, 20 true. It's a tricky problem, but I don't think it's beyond you. I think if you just walk through it systematically, understand lambdas and list comprehensions, you can figure this out. Okay, So now, on to another one. F equals lambda x plus x. Oh my gosh, what's going on here? Well, we have a lambda function, and then there's like a lambda function in the lambda function. What is going on? Let's rewrite this as a, as I was saying, a regular type of function that we might have in Python. So here we'll say def f, and the argument is x. We're going to start with everything to the left of the colon. And then everything to the right of the colon is what we return. So this function just returns lambda x plus x. Okay, maybe that didn't help us too much. We still have a lambda function here. This is a little better, but it's still a little weird. So we can actually rewrite this second lambda function as a function as well. So instead of having a return here, if we were writing this as a regular function, we would say that we define the function within this function. So now we have another function. This one doesn't have a name, so I'll just call it inner function. And right now we're working on this part of the expression, what's to the left of the colon in the second lambda. And you'll see that this lambda doesn't have an x or a y or anything next to it, and that just means it's a function that takes no arguments, which is perfectly fine. We would write this like this, just set of parentheses, and then this would also return something over here, what's to the right of the parenthesis, to the right of the colon in this second lambda. It's going to return x plus x. Okay, so that's the inner lambda, and again, this outer lambda is just going to return this inner function. So we set f equal to a lambda function that returns a lambda function. It's a higher order function, returns a function. Looks very weird. It's sort of tricky to get used to this syntax, but it's no different than what you've already seen in Snap and Python, just defining a function in a function and returning it. Okay, so this is what we have. This is what f equals, and now we're calling f of 2. Okay, what's that going to do? Well, let's walk through it. I think it's a little easier in this notation in the text editor. We're going to set x equal to 2, call f of 2, and then we're going to define this inner function. That's great, and then we're going to return inner function. We never even used x. We just define this function, and we're going to return it, and that's what this expression is going to return. So sort of a tricky question, but this is just going to return, I don't know, a lambda function. So that's what you would write. That's what this outputs, because we never called the inner function. We just wrote a function that returns a function and called it with an argument that never gets used. Great. Now down here, things get a little more interesting. So again, we have this nested lambda thing. Let's write that up here. You'll notice that it's pretty much the same. We can write it again from scratch. So actually get rid of this one so it doesn't have the same name. We'll define a function f, which takes an argument x. And what does it return? Well, it returns a lambda function. So let's say we're defining a function within this function. We're defining inner function. And here this takes no arguments. And it returns x plus y. Okay. Then this outer function returns the inner function. That's the equivalent without lambdas. All right. So this is the function that we create. We also set the variable y equal to 3, and then we call f of 2, and then there's like some extra parentheses here. Let's not worry about that yet. Let's just do f of 2. So f of 2, we did that in the previous example. That's just going to say, call this function where x equals 2. It's going to define this inner function, that's fine, and it's going to return the inner function. So f of 2, this part of the expression right here, is just going to evaluate to a lambda function, specifically this lambda function, the inner function. So now we have a lambda function, and that's why there's a second set of parentheses here, and this is perfectly fine. It's not going to error, because now we're going to call this inner function with no arguments. The parentheses, sort of like call in Snap. Snap, you have a function as data and you have to use call with inputs. Python, you just add parentheses with arguments. And so we add parentheses here, and this function takes no arguments. So we just add an empty set of parentheses. And that's all this notation is saying. It's saying call this lambda function with no arguments because it takes no arguments. Okay, but what's that function actually going to do? Let's look back here. We call it with no arguments. It's going to return x plus y. Interesting. So you might think this will error because we didn't pass in an x or a y. We never set x or y equal to anything. And we're just saying return x plus y. So won't Python be like error, variable not defined in scope? But it actually won't do that because Python is able to recognize both x and y here. So first, what is x? Well, remember, this function was defined inside this outer function. And we already called this outer function with x equals 2. So this inner function has access to anything defined, or any variables defined or passed into the outer function. This is a little weird. In Snap, you can't define a function within a function, so we didn't really talk about this behavior when we talked about scoping in Snap. But I think it makes intuitive sense. If I pass in x to this outer function, and then I define an inner function, I should be able to use x in that inner function. If you want to learn more about how this behavior works, take CS61A, but all we'll say here is this sort of intuitive explanation. I passed in x equals 2, and so I can access it here. And so Python will recognize that x equals 2. And what about y? Well, y, that's very similar to what we did in Snap. Y is just a global variable. I can access it anywhere in my program. Y equals 3. So I'm going to get 2 plus 3 and return it. And that's ultimately what this expression is going to return. 5. All right. And the final one. Hooray, we don't have nested lambda functions. We just have this simple clean lambda. Okay, great. So we're going to set g equal to a lambda function. Maybe you don't need to rewrite it as a regular function because this one's simpler, but let's just do it. We're going to define a function g. It's going to take an argument y, and then we're going to return x plus y. Great. Then we're going to call g of 2. Fine. So we're going to set y equal to 2, and then we're going to return x plus y. And again, you should be asking, where's this x? I didn't pass it in as an argument, and you might think it will error. And in this case, in fact, it will error. We never defined x. It's not a global variable. It's not like this isn't within a function and we passed it in. There's no x. Python doesn't know what x is. It's going to return an error message. So our answer is just so that's all the problems from the worksheet. Again, these are sort of tricky. We have lambdas within lambdas, and we have passing functions as data, and we have tricky things with variable names. But ultimately, if you understand the rules that the computer uses to execute Python, and you just walk through these examples systematically, you can always arrive at the correct answer. So you may see similar questions to these on your final. If you do, don't panic. Walk through it step by step.